Our project is a car price prediction, and we used a used car data set to complete it. We made this website because we wanted to improve the hard and stressful process of purchasing a car, helping people make informed and right decisions when it comes to buying a car. To do so, our model will take the user's input on specific car characteristics and predict a selling price based on the given information. This allows consumers to buy a suitable car for themselves that is also within their budget. We cleaned our data by receiving advice from experienced coders, and through some trial and error, when scanning through our data, the team was able to identify and correct data that was unclear, unnecessary, and negatively impacted our project. Cleaning our data was necessary for the success of our project because the raw and touch data contained incorrect and missing rows of data, which can lead to many inaccuracies when turned into a model. By cleaning our data, we can prevent these errors from occurring, therefore making our model present accurate information instead. We had to remove outliers within our scatter plots because unfortunately there was some numbers that skewed our results, and overall just made the graph unappealing. And since these outliers were highly unnecessary due to them having a high probability of being in error, and also making the graph look less aesthetically pleasing, we removed any values that are abnormal compared to a specific amount. For the exploration of data, we made use of a car data set and a library that helped us train the AI, making as correct a prediction as possible. We used many graphs and charts to visualize the data we have collected.
We used scatter plots to show the relationship between an aspect of the cars and the selling price. So the first scatter plot shows the relationship between the kilometers driven and the selling price. And as you can see, as the kilometers driven increases, the selling price decreases. For the second scatter plot, it shows the relationship between the max power of the car and the selling price. And as the max power increases, so does the selling price. And for the third scatter plot, it shows the relationship between the engine and the selling price. And as the engine increases, so does the selling price. For the box plot, it shows the relationship between the different brands of cars and the selling price. So the boxes represent the average range of the selling price for each brand. And the lines in the center represent the median of the selling price for that brand. And the lines extending out represent the remaining data, and the dots represent the outliers of the data of the selling price.
Here we have a bar graph. This labels all of the brands of cars and their average prices from their models. This can help individuals create a budget on how much they are willing to spend on a car. And here is a pie chart that shows which brand of car is most common. This allows people to see how easy it will be to find the car they're looking for.
The correlation matrix plot shows the relationship between two variables. The relationship between the two variables has a positive value. It means they have a positive relationship. If the relationship is negative, the variables have a negative relationship. The most positive or negative values in the correlation matrix means it's a stronger relationship. And here we have a histogram, which basically shows the amount of cars sold proportional to the year the car was manufactured. Just by looking at the trend, the more recent the car was manufactured, the better it sold. Here we have regression modeling. The regression model helps us understand how our AI will predict where the prices will go in accordance to our data.
What's up, dude? The scatter plot is the result of the machine learning algorithm. It compared max power to selling price. The split we used was an 80-20 split. In our regression models, we used a couple of different methods to measure our data. We used mean absolute error, mean squared error, and root mean squared error. The MAE is the average value of difference between the predicted answer and the correct answer. The MSE is the amount of error in our model. The RMS is the standard deviation between data points. And for linear regression, we have a mean absolute error or mean absolute value of this, mean squared error, and mean squared error. The reason why the values are so inflated is because the numbers here are also inflated as well. Ridge regression, mean squared error, mean squared error, and the decision tree. This one was actually one of our best ones yet.
So this is our classification models. So what classification is, it's like grouping the data into non-number groups like yes or no, or like true and false. So for the classification, we use 3 models. We use the SVC model, the random forest model, and the logistic regression model. And the data didn't work too well with the classification because there was an imbalance of data. There was like not a lot of no's and like not a lot of yeses. So if it just guessed no, you get it right most of the time. We don't want that. We want to just guess no only. We tried to fix it all, but in the end, it was kind of just like 50-50. So the classification stuff didn't really work out too well for us. But in conclusion, the decision tree was our best model. It had the lowest MSE, MAE, and RMSE. And the classification stuff didn't really work too well, but we still had lots of fun like creating and figuring out how it all works. And why does this matter? This project can help people who like need a good card for good price and can fit any person's specific needs. And that's all we got. Thank you.